Now our last example, we're going to look at example 7.5 from the Excel guide. And this is the same basic scenario as in the previous example, except that we're dealing with a blood pressure lowering medication as opposed to a cholesterol medication. And so we have similar parameters. Mu1 is the mean blood pressure of all patients on the drug. Mu2 is the mean of all patients on the placebo. Our hypotheses are going to be the same as the previous example. Mu1 equals mu2. Mu1 is less than mu2. Now, a difference between this example and the previous example is that in the previous example we were given simply summary statistics from our data. We were given just the sample mean and the sample standard deviations. But in this example we're given the raw data. And so what this raw data is given here, this says that the first person on the drug had a blood pressure of 125. The second person on the drug had a blood pressure of 130, so on and so forth. The first person on the placebo had a blood pressure of 145. The second had a blood pressure of 140, so on and so forth. So when we have raw data, we can use some built-in commands to Excel to do our t-test. So if we go to the worksheet difference of mean in the Chapter 7 workbook, now this worksheet is going to be blank, and that's because we're not using any formulas that I've built. We're going to use some built-in formulas to Excel. And so first thing you want to do is enter the data just like it appears here. Put the data for the drugs in for the data for the people on the drugs in column A and the placebo in column B. So enter it just like you see it. Then we're going to select data, data analysis, and then you're going to get a window, a pop-up window that looks like this. And you're going to choose the one of the last options there called t-test for two sample assuming equal variances. So this is a two sample t-test, and as we stated in our requirements, we need to assume that the populations have equal variances, and so that's why we're choosing this option here. So once you choose, so select that option, press OK. And then you'll get a window that pops up that looks like this. And so in this first blank, you're going to enter the range of your first set of data, and then here the range of your second set of data, or I should call this the first sample and the second sample. And so this is for the drug and this is for the placebo. Here we're going to put the hypothesized mean difference. And so this is we could think of this as the number that appears in the null hypothesis. Really, there is no number in the null hypothesis, so we'll just take that number to be 0. Choose this box labels, and that's because we entered labels for our data, and then alpha is 0.05, that's our significance level. And then for output range, just select any blank cell. I chose D1, but there's nothing special about that number. And then you're going to press OK. And when you press OK, we're going to get some results that look something like this. Now you may have to resize the width of your columns in order to see those results, but this gives us a lot of information. First, it gives us the sample mean of the sample means of each of our samples. So the drug, for those on the drug, they had a mean blood pressure of 130, and for those on the placebo, they had a mean blood pressure of 140. Now notice that this mean for those on the drug is less than the mean on the placebo, so our data appear to support the claim. Here are the sample variances. Remember, the variances are just the square of the standard deviations. So if we want to get the standard deviations, we can just take the square roots of those variances. This gives us our sample sizes, 9 in both cases. Here's that pooled variance, which is similar to the pooled standard deviation. Here's the hypothesized mean difference that we entered. DF stands for degrees of freedom. The book talks about doing this hypothesis test by comparing the test statistic to a critical value. This degrees of freedom would determine what critical value we use, but we're not doing that approach. We're taking the p-value approach. Here's the value of our test statistic, negative 1.83. And then here's the p-value for a one-tailed test, and then this number here is the p-value for a two-tailed test. In this case, we have a one-tailed test, And so there's our p-value 0.042. This cell right here gives us a critical value for a one-tailed test. Again, if we wanted to do this test by comparing the test statistic to a critical value, this would be our critical value, but that's not the approach we're using. We're doing the p-value approach, and so this is our p-value here, 0.042. So we'll interpret that p-value in the same way as every other hypothesis test. Compare that number to 0.05. In this case, the p-value is a little bit less than 0.05, and so we would reject the null hypothesis in favor of the alternative and conclude that the data support the claim, or stated another way, that the new drug appears to be effective. So if we ever have raw data, we can just enter the raw data into Excel and do these commands that we just talked about, and it will take care of everything for us.